Welcome to qnawire.
So we want to refer to the formula for the net charged enclosed by a closed surface, and it looks like this. And what we want to do is we know that we can divide S into 6 parts because there are 6 faces of the cube. So we want to find the flux through the face of the cube, which is part of the plane x equals 1. So one thing we can note is that this right here is the same as this right here. So what we're going to do is n is going to be the normal vector, and therefore n is equal to I, since we're talking about the plane x equals 1. So this right here will ultimately end up equaling the double integral, since we know E to be x, y, z. That's going to be times or dot I ds. Then when we do this, when we dot this, another way of looking at this would just be 1, 0, 0. So when we dot these, it's clear to see that this will just be x ds. And since x equals 1, it'll just look like this. So then the surface area of the face of the cube is going to be 4. So that will just be 4. And then finding flux through the face of the cube, when it's x equals -1, going through a similar process, we'll end up seeing that what we get is what we'll get is a -1 right here. So we'll just end up having a negative x. X is -1, so this will just become 1. So then we get 4 again. That's the area of the face of the cube for x equals -1. So essentially, we note that both the surface and E are symmetrical in terms of x, y, and z. So the flux of the 4 other faces will also be 4. So since each face is 4 and there's 6 faces, that tells us that the net flux through the cube will be 24. So essentially our charge enclosed is going to be, remember this is just what we saw for here, that's 24. So our total charge enclosed will be 24 epsilon naught. And that will be the final answer for this problem.